beginning. But anyways, thank you again. Filtration. Basically, at GoEQS, we would like to have some recommendation when it comes to ventilation and filtration. We want to develop something like a standard because there are already many out there. When we talk about ventilation, lots of people agreed that they use ashtrays, and here in Europe, they're using the European standards when it comes to ventilation. Uh, but we wanted to learn a little bit more of what's the best way to approach indoor air quality, and those two means, filtration and ventilation, are, I think, fundamental. So we will go through the some slides that I have prepared based on the feedback we got from the voting period. And please, if you have any comments or you would like to add something, feel free to raise your hand and share your opinion. So the first one was a question regarding take the polls, if you like, about which filtration technologies do you trust. Now, we tried to summarize them and categorize them on different groups. That's not always the case, as we discussed a little bit earlier during the ventilation, because some of the technologies out there to mitigate air pollutants may have like a variation of them, and some variations may work and some other variations may not work. So let's see. For mechanical filtration, so everybody agreed that they trust. It's proven, like HEPA filters, MERV filters, they work to their specification. Of course, a MERV 4 is not the same thing as a HEPA filter, but I mean, they are gonna do whatever they are designed to do. Absorbents like activated carbon, they are also the majority of the people agreed that they trust this kind of technology. From my personal experience, I also trust them, but I know that they also saturate very fast when it comes to absorb some of the gases out there. Again, if you would like to speak, just raise your hand and I'm more than happy to incorporate you in the conversation. And I see already, Andrew, you have raised your hand.
Yes. So I understand that the danger with activated carbon is that it can release what it's captured if there is a dramatic temperature change, which could happen in a climate that has 4 seasons like that I experienced in southern Ontario in Canada.
Mm-hmm.
Is this a commonly understood vulnerability with using activated carbon?
I think yes, and also the duration, how long do you use it, right? Because when we talk about a carbon filter, basically we talk about a porous substance that absorbs or traps some of the gases inside them, right? But now if you change the conditions, like what you said, increasing temperature, you eventually may also increase the size of the pore, and also you may allow those gases to, again, exit the filter.
Yeah, it's something that unfortunately is not well understood. The danger of leaving the filter in the system.
Mm-hmm. Yeah, and as I mentioned earlier, like they can saturate really fast, especially if you, let's say you are trying to trap a VOC, a specific VOC. It may be good for a certain amount of time, but after like a short period, it's gonna stop working basically, and it's gonna allow the pollutant to pass through.
Yeah. You put your hand up.
Then we have, okay, Charles, please.
Yeah, so Terios, my thoughts on, well, firstly, if there's sensors inside the building, those will pick up the spike once it's saturated, or it should give you some form of warning. So I think what we're going sort of full circle to, which is one of my key areas of interest with infiltration, which is energy optimization, both in terms of being responsible because of how energy is created, and some of the most industrialized countries are still very reliant on coal power. So, I think that an area of discussion and focus from that is with the use of technology, optimized maintenance and housekeeping, and that's where and best practice in doing so. But in terms of the VOCs, in terms of loaded filters and the resistance they're creating, and of course the coils, and I see it as a very holistic thing actually.
Okay.
I just wanted to say that. And I know Quan and I discuss this, most days as well, because he comes from the energy, his focus is the energy optimization side as well.
Okay, thank you for your comment. And then we have those electronic filters, again, like what I mentioned at the beginning, ionizers, they may have variations of them, and as we already mentioned, they may work or not. We have other solutions like electrostatic filtration, where basically, in most cases, we will have something like plates and some kind of a line that is going to charge particles in order then to stick on the surfaces and not allow them to continue their journey throughout the purifier. Again, some people, let's say, they don't trust it, or in this case, only 2 participants believe that they work. Okay, we have to hands here. Andrew, please.
Yeah, so I'm seeing a number of companies that are now coming out with these products and making, and their key advantage that they talk about is that they're able to get something like 8 to 10 times the capture rate of a typical filter by creating a small electrical charge, creating a magnetic field around, static field around it. And one company that I know that I won't mention says that they have like a MERV 4 or 5 product that acts like a MERV 13. So it's a MERV 4 or 5 in terms of static pressure, but MERV 13 in terms of effectiveness. Has anybody measured any of the byproducts? If there's anything that these are generating, as in the discussion we talked about hydroxyl radicals?
So I have tested electrostatic filtration. Are we talking electrostatic, right? Not bipolar and electronic.
Yeah, this is just talking about the small voltage charge that creates static.
So I have tested the efficiency, not about byproducts. And on my test, they worked, like they are able to capture those particles. Now, they collect those particles in areas that you have to clean in higher frequency in order to avoid agglomeration and eventually releasing of those particles again back to the environment. So they had this kind of obstacle in my tests. And that's from my side. Juan, you have raised your hand as well.
Yeah, I completely agree. Well, you all know that we are experts working in with these kind of different technologies. And yeah, if any one of you wants to, well, I mean, the most important thing, I completely agree with Andrew. I mean, there are several different technologies out there. Most of them, they don't really know exactly how their technology works because nobody manufactures anything. They all design and manufacture mostly on China, and that's something pretty cool. I mean, my point is that out there, many companies are just dealers and not really engineers of these kind of technologies, right? Some of the ones that are following us today in this meeting, yeah, they are manufacturers and they have a deeper knowledge. Just in case, I wanted to add, based on what Andrew said, that yes, it works brilliant. This kind of technologies works brilliant, but you have to concern about watching out that the fact of these different technologies, they are not ionizing air, because just in case they do, then they would be producing substances like ozone, but not only ozone, whatever oxygen radicals are, and there are a lot of them. So that's why ASHRAE says that they must accomplish with the known byproducts certification. And my point as a specialist is it's okay that you are accomplishing with that. But just in case you do, you should test in a lab exactly what kind of byproducts you are not producing, at least for the people willing to install these kind of technology in their buildings, because we should we should concern and we should always watch out about the prevention risk standards and the mandatory obligations we have to accomplish with,
Juan,
because
I
no
completely
harmful. Sorry, Lula. I'm just finishing. I'm just finishing. With Because no pathogens could be ever, and no amount could be ever poured on the ventilation duct, and even well, sorry, I got lost in English. I got lost in my in translation. I mean, yeah, you can pour some pathogens on the actually based on the standards. Yeah, you can pour some pathogens on the ventilation duct, but you will have to assure that no pathogens, no quantity of those pathogens arrives or achieves the breathable area. Because you won't find these on any building standards. No, you just will have to you will have just to accomplish with the prevention risk, because there are people working on buildings, even when we are talking about dwellings, because there are some housekeepers or whatever coming to your house to work on it. So the right to safe workplace prevails over whatever you're doing on your installations. So first is first, and safety is first, even before the indoor quality or whatever. Just to end this message, just in case you guys would like to see some certified by third-party labs in a serious way,
Mhm.
based on how you can increase indoor quality based on electrostatics. Electrostatics, not all the well, you will you will have to check deeply those electronic filters, which actually ionize air. That's the first signal of big concern. But if we're talking about electrostatic precipitators, yeah, they work brilliant and saves a huge amount of energy.
Lula wrote a message.
Yeah, yeah, I'm gonna explain a little bit further. Sorry.
Mhm.
So I completely agree with Juan, and I wanted to. Sorry that I interrupted you. I thought you were done. I wanted to pick in where you left off. The need for the testing of byproducts. We have done extensive research of trying to find a way to regulate this and create a test formula for this. But we found it very difficult because it depends on the composition of the indoor air or the outdoor air, depending on what it filters. So we couldn't find a way that was, especially not for Belgium, we're a small country, small market, to justify this testing method. Um, Also in real life conditions, because yes, you can test for oxygen radicals, and the main test you can actually only do is ozone testing, which is very cheap, very well thought out of, no problem there. There is some test protocols that we also use, which is harmonized, but the other byproducts are depending on the composition of the indoor air, and we really struggle with finding a way to determine these and test these. Um, so if anyone has any experience with this kind of problem, we're more than interested in hearing your point of view, um, because yeah, we can only ask at this time. We can only ask for the ozone testing because it's so difficult to determine. I'm also gonna. So we have the legislation that I posted in the last meeting. I will also post here.
Yes, please.
But just a small recap, our National High Health Council actually fully approved tree filtration products, which is especially for viruses in aerosol. Like I said, we are working on expanding the scope, but for now it's only legislation against viruses in aerosol, which is mechanical inert filtration HEPA 13 14 and EPA 12 in integrated systems, in ventilation systems. Then electrostatic filtration with precipitation, and UVC, but only within the 240 to 260 nanometer limit, and not outside. And that's also the UV is under the condition that it has 2 to 4 air changes per hour as well, to eliminate the risk of photochemical smog. We also prohibit the following techniques, which is just ionization of the room, photocatalytic oxidation of solid substances, also cold plasma, and then distributing ozone or H2O2 is hydrogen
Peroxide.
peroxide in a room with people in it. So these are the techniques we, at this time, say we don't allow. They can ask for a derogation on our legislation, and then they have to come up with a proof that they are safe and efficient in use. But the basis is that we don't allow them on the Belgian market for high efficiency filters against viruses and aerosols. Yeah,
Thank you. Andrew?
Yeah, I hope I'm saying the name right. Eula?
Lula, but it's
Eula. Okay, Eula. Okay, sorry about that. And by the way, you got some great croissants in Brussels. So I'm curious, did you test, as part of your test protocol, did you use PDIs or did you do air sampling, whether passive or active?
So we didn't, we don't, so we only do academic, and administrative tests. We don't do lab tests, but in creating of our legislation, we did the mental exercise of creating a test that would incorporate these types of byproducts. But just the design of our experiment was too expensive and too difficult to demand for each product on the Belgian market. So we didn't fully create a test protocol for it. It was a rough drawing, and even then we saw that it wasn't maintainable right now.
Thank you.
Juan?
No,
Your
yeah,
microphone.
I'm so happy to hear Lula and to hear Andrew. Well, I didn't know Pedro before. Well, I don't know Pedro, but I know exactly what Charles thinks about this. So I'm really happy to hear that you guys, Lula, you guys are working on that path. Actually, probably all of you know that these kind of electronic filters that they work with high potential differential in between anode and cathode, what they are actually doing is the corona discharge, and that's why I say previously in the other meeting. I mean, there's a lot of brands out there explaining their capabilities or whatever, and they are not actually understanding what or how the technology really works. And what's the problem with that corona discharge thing? Well, actually, it's that they are actually ionization. They are ionizing air, so producing these oxygen radicals, which are actually all of them biocides, and that's the reason. That's the reason to not being allowed in the breathable area, right? So I'm so happy, Lula, about that, and I can tell you that yes, those testing in labs, in third-party labs, just to ensure that what you are installing inside the building or whatever, they're quite expensive, actually. For instance, my company, and every single installation we do, I don't know the term in English, because there might be a difference between an indoor quality in a third-party indoor quality testing lab or one of those indoor air quality testing labs that are part from the government administrations, and we just work with that kind of. It's like in the United States, probably, Andrew, in Canada, you may know NREL, NREL, here in Spain, probably, well, in Europe, we know Bureau Veritas or AENOR or that kind of high companies or testing labs or certification labs. That's the term. I mean, you will be needing a certification lab if you're installing these kind of technologies to improve filtration. And as you are improving filtration, being able to achieve the same indoor quality, so being able to justify based on the ventilation standards, actually, which is something contrary to, sorry, not counterintuitive, that's Spanish. Jesus, I got stuck. Sorry, guys, I got stuck in what I was trying to say. This is un unintuitive, the opposite of intuitive. I can remember the word. So, um, yeah, our point is that you are able to reduce ventilation actually if you're increasing filtration, if you're increasing filtration capabilities with these kind of technologies. But watch out on what you are installing, because probably you will be causing this filtration increase, which is quite good for energy savings, but maybe you are producing a very serious problem inside the building based on the usage of biocides, which are not allowed. So, Lula, thank you very much, because your government is, in my opinion, working on the correct way.
Yeah, we hope so.
Thank you both. And to continue the discussion on the slide, and then we had UV filtration. Obviously, UV filters, they don't capture anything. They just deactivate or they kill some kind of pathogens. And 3 out of 8 people agreed that like they trust this kind of technology. Of course, then we have the last one, which is the photocatalytic oxidation, which we already talked a little bit, and only one person trusts this kind of technology. The active electrostatic screen, I think it belongs to to the electrostatic filtration, but it was it was an input from one of the members as an extra recommendation, but it actually belongs underneath this
Yeah,
category.
it's our product, Soterios. And which Juan knows very well. He's been playing with it for a couple of months now. It's based on electrostatic principles, but it's not an electrostatic screen or filter as such in the traditional sense.
Mm-hmm.
Yeah, which.
And as every coin has two sides, then I ask the same question the other way around. So which filtration technology you do not trust, right? And we will see that the HEPA mechanical filtration in general, no one participate on those two, and also the activated carbon type of technology. But then we do have some conversation happening with electronic filtration. Some people, the majority of the people, they didn't trust it, alongside with the photocatalytic oxidation. I'm skeptical about the above someone mentioned, and what I do not trust is the I don't remember what they wrote here. Probably they say the misinformation or the fact that some cases, some products like bipolar may fall under those categories where you believe on it or you don't believe on it. Some of them work, some of them you don't work, and so on. How important is energy efficiency on filtration systems in buildings? The majority agrees that it is very important. So I don't think we need to discuss that. Juan, you have another comment?
No, yes, I just wanted to add in the previous yeah, in the previous slide. Yeah, I mean, it depends on does these technologies work? They certainly do. All of them, they work, but they work for specific situations. I mean, for instance, yeah, we all agree that that carbon filters will work with others, but will have no capabilities with other particles retention with particle filtering or something like that. So, for instance, photocatalytic oxidation, yeah, it works and works really as a biocide. Yeah, it works really good. UVC lights, well, they work actually. They work for sure. That's something that has been widely proven. But um, it works fine in stationary air, not in velocity, not in a dot, because you won't have enough time to kill bacteria or whatever. Yeah,
Mhm.
you can make a sort of UVC tunnel on your ducts, and yeah, it will work. So it depends on the airspeed, right? So my point is, and this is part from the work we will have to do doing the categorization of different technologies, is to explain the people reading the GoAQS standards which are the goals of every single technology and which are the restrictions of
Yeah.
usage of these technologies. Because, for instance, you can work with those plasma electronic filters, and they work fine as well as a biocide, but you will have to watch out to ensure that you are installing those upstream from the filter and never downstream. But for instance, yeah, with the electrostatic filtrations, for instance, the technologies we are using, we have proven by these third-party labs that we are not producing no biocides or not harmful substances or something like that, because we are not ionizing oxygen, so we are not producing substances or these byproducts that are not allowed inside the building.
Mhm.
So in this kind of technologies, yes, you can use it downstream the filter because we are actually particle precipitators. So yeah, in the breathable area, it's quite interesting to use precipitation. Why? Because you will change the gravimetric composal of air, doing particles larger. So these larger particles will weigh more and um, um, will be
Absolutely.
yeah, precipitated on the floor, right? So that's not, well, that's related to filtration, because your first and most important way of achieving indoor quality will be forever the mechanical filters. That's uh, out of discussion, I guess. But yeah, you can use those different kind of technologies on strategic points, or on a specific moments, or places in your ventilation and air conditioning installations. But not
Mhm.
all of them will work on every single situation. I'm sorry, I know that my English is crap. Just to be
That's the reason, Juan, we
absolutely.
ask which one you trust, not which one works better than other, but which one you trust and you use basically on your work, right? And that's the reason we receive those kind
Okay,
of
then
messages. But it's okay. It's
sorry.
very good you clarified a little bit further that certain technologies are used in specific applications. And now, when we talk about indoor air quality in residential areas or offices, schools, maybe some of them are not the right tools because of all the problems they may create while they operate, right? Um, Now let's move.
Yeah.
I One of the questions that I asked was, what is the most energy efficient way to remove particulate matter from indoor spaces when the source is coming from the outdoors? And the majority of people say like mechanical filtration. Uh, Always ask 311, remove the pollutant or filter it at the source. Obviously, you have to remove the pollutant, but outside it's not the case, right? Like if wildfire is happening, what are you gonna do? And that was one of the questions that raised during some other sessions that we had this week, like how we can keep up with excessive ambient air pollution, and how we can protect occupants in buildings with limits that may not be easy to achieve in those scenarios. I don't know if someone has any comment on that. I mean, the limits are the limits, on my understanding, and whether now something outside of our control is happening does not mean that we should be more flexible. Does anyone believe the opposite or otherwise? I would like to hear. Filtration, also mechanical filtration in duct filters in natural ventilated buildings, portable air cleaners can also be used. And some other comments, we can use ionized bipolar cone filters, mechanical filters to do this kind of filtration. And also, I will assume they mean like combining various technologies. They can help us achieve energy efficiency without compromising on air quality. But of course, without technology, that they are not gonna generate other byproducts like ozone. I'm just translating a little bit the message in English that it's written in Spanish. What is the most energy efficient to remove now PMs from indoor source when the source is indoors? Now, it makes sense to say that you have to remove the source, right? Like it's on your hand probably to do it so. And again, they're talking about bipolar ionization, the soft version, mechanical filtration, portable solutions, freestanding HEPA or HIBO screen, portable air cleaners again, opening the window, filtration, mechanical ventilation are also in the comments. Yes, Juan?
No, I just wanted to add about this slide that even when I said that this electrostatic technologies, even electronic technologies, works fine in combination with filters, I have to reckon that based on our measurements. Well, when I say our measurements, I mean the third-party labs. If the source is active, then the results are really weak. So this has sense. I mean, if you are doing a sort of previous analysis on the pathogens or the problems you have on Earth, and you are pretending to combat those problems with different technologies combined with filtering, yeah, the first step always has to be to stop the source of the source of the problem you have inside, right? Because in other way, if you are pretending to use even our technology, and I have to recognize that, because we realize in different situations that we were expecting to have a really good result, and then our result was not that good, and that's I explain that in a sort of very simple way, because I'm a smoker, as you all have noticed probably, and yeah, we are able to reduce, even to remove smoke particles from air, even the odors, yeah. But if someone is smoking, you won't ever be able to get rid of that. So the first thing is just to take that guy smoking outside and not inside the building. Makes sense what I'm saying?
Yes, absolutely.
Okay, cool.
Yes, when we talk about a source of pollution that it's from the inside, you have to remove it, right? It's on your hand, possibly, or more likely than a source that is outside the building. And that's the reason I specify in the question, apart from removing the source, right? But okay. What is the most effective energy efficient way to remove PM from indoor spaces when the source is indoors? Also, they said those kind of details, which I don't remember who wrote that, but if he's right here, please elaborate more. Charles, I see you have raised your hand.
Yeah, just one quick sort of question statement with regards to removing PM from indoors. Should he, presuming already you've got a decent filtration that works, surely recirculation is key, because recirculation, actually, I didn't see it on the slide. and adjustable recirculation being potentially incorporated.
I think they're
Because-
referring to the portable purifiers with the recirculation. Maybe we can consider them as recirculation as well, right?
yeah, correct. But I mean, you've already got a filtration system, and you can adjust the amount of recirculation to basically filter it out using your existing infrastructure. No?
Yeah, of course. If you have like a central system that can handle something like that,
Yeah.
like closing and now recirculating the air
Yeah.
from the inside, yes.
And adjusting the mix. Yeah.
Yes. So I don't remember who wrote that message. I don't know if he's in the conversation right now. But basically, they provided some more details on the specific filters and what they can do on the different sizes of particulate, and what they are personally doing in order to mitigate pollution from the indoors. Like, for example, they say, I ran in my house a MER 15 with MER 15 pre-filter, with an initial static of 0.3 WG. I ran my blower at 24/7. It never turned off. I have been at 0.23 WG initial static for 6 months. Per residential AC requirements, I have to replace my filter when it gets at 0.8 WG. I will not need to replace my filter for over a year with no static pressure issued and with full filtration performance. I want to say that that was Mac, but he's sick and he's not here today. Ventilation, it's another way. I mean, if you don't have this mechanical ventilation system in hand, you have to open a window or two maybe in order to create this cross ventilation and flush the pollutants outside of the window. Because, okay, so in this question, I'm asking what is the most effective way to remove those gases from the indoor space with filtration means. And they've mentioned again the activated carbon and absorbents. There are some other absorbents out there. I have seen some purifiers that they use some kind of a gel to absorb substances. I don't know how good they are or not. Does anyone have ever tried those kind of products? Okay. Has anyone tried to use water in order to remove some of the gases, like NO2, for example? No, I have seen those as well, but I don't know how
I
well
know
they
of a
work.
company that uses water aerosols to decontaminate spaces from biopollutants
Okay.
under high pressure, but not from gases.
I had a meeting, a few meetings with a guy called Ioannis from FCA Hygiene in Greece. And they're developing and beta testing a water-based solution for both filtration and gases.
Okay.
Yeah.
So maybe we can make an assumption that it's on an early stage to use those kind of means like water in order to remove some of the gases from the air.
I can comment here. Just
Yes,
I
please.
had a personal experience where a painter, I don't know how, in my basement renovation, painted with oil-based paint. And it was a perfect accident because I had stepped out for about an hour. When I came back, realized that the base was oil-based, and we put 4 or 5 pails of water in various locations of the basement. And within about a day, it looked like it did relieve some of the smell.
Okay. So possibly the water attracts some of the gases coming from the oil paint, or
That's what it was his solution. And he
Okay.
said that he's done it before. So kind of homemade, very low tech.
Yeah, I've never heard of this one actually.
There are also types of paints that say that they absorb VOCs, and I don't know if they really work. I just know that they do, and market it that way. And then like the Guy Rock. I don't know. I need to find a word in English, and I will get back to you. The home improvements plaster plates.
Yes.
Plaster plates also trap VOCs apparently. at a very high efficiency.
Mm-hmm.
Yeah, so Lula, I've done some testing on that. I can speak to it. So we've used graphene in paints with graphene in it, and did some testing with it. The difficulty with the graphene-based paint that we did end up using was that you needed to keep a wet edge, and not many painters on a production basis, because I'm with a large home builder, will have the patience of painting only a little bit of the trim and then rolling right away, painting a little bit more of the trim and then rolling right away. Normally, they'd like to paint the trim, all of it, and then start rolling, and then you'll end up with the lines. We've also used a line-based with graphene plaster, and it's extremely attractive because the wall looks like it's stone afterwards. And the claims, which we've never substantiated, are that it absorbs moisture and CO2 and releases it. Company's fairly substantial. They got a lot of substantial marketing materials for it, but we've never done the testing to determine whether they substantiate the claim.
I've seen the same solutions as well, and there are some other companies that they have paints with titanium oxide on them, but then they will need sunlight in order to activate the catalytic processes. But again, they may produce more harmful byproducts than removing those VOCs from the environment. And when it comes to the limestones, I have seen that as well. Basically, it works the same way as an absorbent, like carbon, as it has many pores, and some of the pollutants can be trapped inside the paint. For how long? I don't know. That's another question. Juan?
No, I just want to add that yeah, we have some wide experience based on reducing VOCs indoors, and once again we do that based on electrostatics. So you may understand that whatever that passes through an electrostatic field will be affected by that electrostatic field, depending on the strength of the element or particle. I'll try to explain that again. Just consider that every single element of the chemistry table will have an ionization energy, right? So whatever passes through an electrostatic field, it has more energy, more ionization energy than the energy produced by the electrostatic field, will be able to cross that energy field without being affected, right? But if it has equal energy or less, then it will be affected by. So why I'm explaining that? Because yeah, we have wide experience on reducing VOCs, because particularly in VOCs, which are basically carbon chains, sorry, the bonds, the carbon bonds are pretty weak compared to other elements as oxygen as well, as an example, right? So yeah, based on electrostatics, you're able to reduce up to the, we have already certified that in the most well-known European, in the most well-known European chemistry of a lab, which is in France, actually. It's called Terra Labs. And we have reduced concentrations up to the 60% of total VOC indoors, right? While we were actually as well reducing particles, working with in combination with the mechanical filters. So if anyone is interested in that, yeah, I can share some of the results. We have reduced even acetones, which are pretty tough to be reduced because their bonds are pretty their bonds are stronger than the average VOCs, carbon bonds, right? So I don't know. I'm just available to any one of you if you are interested on that, because we at least we take these what we are doing on indoor air, reducing pathogens and analyzing previously and after what we do, we take that really in a serious way. So,
Mhm.
we never, and this is a suggestion to anyone working in this market. We never take this in an easy way and a la ligera. No nos lo tomamos a la ligera, Sotirios, ayúdame.
Uh, I don't know now. We don't just they don't they have to go through a process of thinking it and not just light thinking it.
Yeah.
Right? Yeah.
Well, actually, our point is that what you are not measuring, and I'm not talking about indoor air quality monitors, what you are not measuring by a lab certifying the results
Hmm.
just doesn't really exist. So it could be a bit expensive, but it's not expensive at all if you consider that if you're doing things wrong, yeah, probably you will have legal consequences and not just civil responsibilities, but also um, 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 penal
Penalties,
penal
yes.
responsibilities, right?
Hmm.
So yeah, you better watch out. So yes, it's possible to reduce COVs, and this what I'm saying, these reductions up to the 60% depends on if the source is active or not. So based on what Andrew was saying about the paintings and all those materials that emit
Hmm.
COVs, yeah, for sure, the curve of reductions won't be plain, you know. While the material is emitting those VOCs, yeah, you can reduce those 60%, but you will be reducing the 60% of the VOCs these materials are emitting. So considering that, yeah, you will have to measure after using any technology to reduce those VOCs, you will also have to measure that you are not achieving the the exposure limits to that COV, because
Hmm.
you will may know that most of them are actually as well carcinogen elements that will affect our health.
Right. Thank you, Juan. For those of you that they follow also the particulate matter working group, we are also discussing having particle count numbers for zero point 0.3 and zero point 0.5 micron submicron particles as a way also to determine whether the filtration systems that we have in place are working properly inside buildings, because they're not checked regularly by inspections that they do. Also, they based their measurements or their results on possibly PM 2.5, which is not the right way to measure how effective filters are. But during some initial discussions that we have in the particulate matter working group, we decided that we don't have the substantial data at the moment to support a limit. So we will propose the particle count numbers to come in a future version of GoIQS rather than this first one. And we will invite people from the industry to provide us with data and researchers also to look into those different particle sizes in order to start implementing them and understanding what's the outcome with the health effects. Because so far what we can see is only one standard around clean rooms and about products rather than the health effect that those particles have on human health, even though we know that they can penetrate deeper, they can reach deeper into the human body, and also depending their composition have more outcomes to the human health. But the academics on our side of GoEQS need more information from the research in order to come at a conclusion there. And finally, we have some open comments from this survey. We should include HVAC AC systems, the seal test certification. We can run the best sealed air filter if the system is not sealed from return to supply, and everything in between, we have failed in our QA efforts. So basically, they are saying that it's very important to have a very robust system, especially when we talk about ventilating systems and HVACs, and not have leaks all over the ducts and maybe around filters, because our efforts for filtration and keeping indoor air quality will never be profitable. Critical factor taken into consideration for trust includes reliability over time, maintenance requirements, dependability, and impact in solid, etc. The literature in air cleaning filtration of gaseous and biological compounds is still scattered and with limitations. There are different methods, technology for different gaseous compounds, and different studies usually use different methods to qualify the efficiency and efficacy of the methods technology, which makes it difficult to establish a comparison. This is true. I have seen this example many times. Moreover, the state of the art is changing very fast on this topic. On the other hand, the literature about air filtration for PM is literally more robust. And that also aligns with the working group for particulate matter. There is so much more information about PM rather than any other pollutant out there. We need to have this into account if the idea is to provide recommendations of air cleaning filtration in the Go AQS white paper and website. I think the recommendations should only be made if there are clear and robust literature evidence to support it. When this is not the case, it's better not to recommend anything, as sometimes the byproducts resulting from some of the technologies may have even worse effects than the original pollutant to remove. Filtration finally offers companies a way to help reduce their carbon footprint and remove rather than dilute particles from the air. That's all for today. Charles, yes, please.
I'm just struggling with that last one a little bit. Why are we saying it would reduce their carbon footprint, which is their energy related carbon footprint and usage? I mean, if your focus is your carbon footprint, if you haven't got any HVAC, you're not using that 30-40% of the energy of the building. And probably the single biggest, it's the single biggest draw of energy in any commercial or other building is your HVAC system. So I think it's about optimization of that, being responsible, but I'm not quite sure how having filtration as a broad rule is a way to help reduce a carbon footprint. I'm just a little bit confused about that.
Right. I don't know exactly what they meant with this sentence myself either. I will assume they are comparing filtration over ventilation, right? Where in ventilation you dilute the pollutants,
Right.
so you decrease the amount of them, but with filtration you actually capture the pollutants. Now, what's the outcome with carbon footprint?
Sorry,
Unless we talk about black carbon, which may contribute, let's say, in the global warming.
Exactly.
I don't know myself either what they do.
Yeah. I mean, with ventilation, you're still using the core components of an HVAC system to move the energy. You just don't have filtration medium. Okay, filtration medium actually causes resistance and makes, and draws more power. So, I just wanted to just add one thing, just going back to the energy slide. It's just the fact that out of 9 respondents, I think we had on a scale of 0 to 9 or 1 to 9, with 1 totally unimportant and 9 obviously, just use the word critical or vital, as important as it gets. That we actually had, I think it's 2 people were 7s, 2 were 8s, and 5 were 9s, which is extremely reassuring and very positive. But I think also it's not the majority think it's really important. Everyone thinks it's incredibly important, and over half of us think it's absolutely critical. I just want to elaborate a little bit on that.
No, thank you. Yeah. Anyone else has any comment? Pedro, please.
Thank you, Sotirius, and thank you very much. Very nice to meet you all. Just a very quick comment, because I think that Sotirius, you mentioned that very briefly a few minutes ago. I think it is important to consider in this filtration, not only in this filtration working group, but maybe also in other groups, these extreme events, because these
Yeah.
filtration systems and all these systems are usually designed based on, let's say, the background scenario, the typical scenarios, and so on. But when we have these extreme events, usually occur, I'm talking about these extreme events outdoors, like big forest fires or desert dust penetration in the cities and in these places, which are very common in the southern part of Europe and in some parts in the US also. But not only, I mean, both of these things actually, these extreme events, which are becoming more and more frequent. I think it is important to have this into account. I don't have a definite opinion about how to consider this in terms of the standards, because in one way, we are interested in defining these standard values or threshold values, which should be to protect people's health. But under these extreme and unprecedented sometimes circumstances, we may need to consider to let's say adapt these standards somehow, or because I mean, if the indoor environment is much better than the outdoors, then it is protecting people already, you know. So it's a kind of mixed feelings here, and I don't know how exactly, but I think that we should definitely consider about how to include this, and about this specifically. And just a final quick note, maybe it will be interesting to contact directly Professor Xavier Querol. He's from Barcelona, and he's probably one of the world's biggest experts in ultrafine particles. He has a lot of studies. He's leading a group there in Barcelona. He has a lot of studies on the health impacts of ultrafine particles, and it will be quite interesting regarding this discussion of including or not, or including in the future, which I assume that is already decided, and I agree with that also. So I think it could be interesting to contact him.
Thank you.
Yeah.
I will meet Professor Carollo in Barcelona, as we are both invited to speak in a conference there in October. I have already reached him about him joining also GoEQS, but he was really busy and he couldn't, but hopefully I will convince him in person. Sharon, please.
Hi. I just want to say, I think that last comment might have been mine, but it was such a long time ago that I can't filled this out. But what that specifically relates to is portable filtration as opposed to HVAC filtration. So in some examples where a hospital might want to increase the number of air changes an hour, if you increase the HVAC system versus adding a portable air filter, there is a difference in the carbon footprint. I think that's what that relates to. But it also does lead on to the fact that if we do have filtration standard, it should be different for portable air purifiers versus built-in filtration in HVAC system, because they won't be the same.
Right. And thank you. Now it makes more sense, right? Like when we talk about like a portable air filtration system, yes, you do have the benefits of not having to lose the energy from and heat from within the building, because you rely on this kind of technology to capture the possible pollutants, whether they are pathogens or just normal PM particles that are floating in the air. Thank you so much for this comment. And then Charles.
Yeah, I just wanted to thank Pedro for raising such an important point. Gracias. It's really important what you brought up. Thank you. Yeah, that's all.
Perfect. So that's all. Thank you. Juan, you have a comment.
I just wanted to add something about the portable filtering thing. Yeah, that's one of the main reasons why in the European ventilation standards, also in the American standard, says that if you are going to use purifier systems or clean air cleaning systems, um, you may have to consider on installing them not only in the ventilation system but also in the air conditioning system, right? And both should have to work combine as a whole as a whole thing, right? So if you attend to this ventilation standard, that's not in the European ones, but it's on the American ones. They are not providing no they are not prohibiendo they're not providing the fact of using um, portable air cleaning systems, but